Hello, today I'm going to show you and present my independent study with Professor Yavuz Yardım. What I have to do is, so I have this architecture plan, as you can see here, the columns, the beams, the grids, the shear wall, the elevators, but unfortunately I do not have the exact measurements and distance between the grids of the shear walls, and I have to leave them and make all the other stuff. Uh, I have to open Etabs 2013. This is a 9-story building. Here is the name and the location, and it is a residential one. What is this? License? Okay. It was a residential one, and we have to model it in Etabs 2013. So basically, the first thing that it gives is this main page where we have to click new model just to start. A new table will show up, is the model initialization. Here we have to choose use built-in settings with we have to choose display units metric SI. Still section database, we have to choose, where is euro code? I can't find it. Euro, sorry. Still design code, we have to choose Eurocode 3 2005, and here Eurocode 2 2004. Click OK then, and after this it gives a table for the grid system data. These are, here we have two options: the uniform grid spacing and the custom grid spacing. As you can see from here, we do not have a uniform grid spacing because here we have 510 and here 625, and we have to choose the custom grid spacing, and here we have to click edit grid data. Again, we have we have two options here. The first one is a little bit difficult because you have to sum up all the ordinates here, to sum, and in this case, that is my preferred one. You only have to put the distance between the grids. So let's start with this. The first one was, let me see, 6 to 5, 6.25. The second one was 5.1, 5.1. The third one was again 5.1, 5.1, and the so basically here we have to add another one because we have 5 grids, and the last one was 6.25. just to be sure, let's check up. Okay, the first, second, the third one here, that's okay, we're okay, and the last one we have to leave it as 0. And this is for the x direction, and this is for the y direction. Let's see the y direction of 600. They are all 600, as we can see, so it's easier for us in this case. 6 here, 6 here, 6 here, we have to add 1 here, 6 here again. So now we have to click OK, and after we finish with grid dimensions, here we have the story dimensions. Number of stories, we have it as 9. Typical story height 3 point, or it's 3. Story sorry, bottom story height is 3.5. So we have to choose here grid only, click OK. It opens 3 windows. The first window I will close it because we will need it later. The first one is plan view of 9-story building, and the second one is 3D view. Basically, the first thing to do is to define material properties. Add new material here, Europe here in region, concrete, and grade C25. Click OK then. The name will leave as it is. Material type concrete, directional, isotropic. Click OK. Another one is region Europe, material type rebar. Click OK. Rebar and actual. OK. Click OK then. After this we have to define the section properties as frame properties. We have to add new property. We have to click here as concrete rectangular section, and it will open frame section property data, and I will name it as column, shortly CL. We have to choose the material C2025, that was our material, and after this we have to make the depth here, that is 600 with 500, and just to be sure, let's check out. Okay, it's column. The design type must be column in the column and the beam in the beam. Click OK, click OK. Now we have to add new property, again concrete section. Now we have to name it as beam. Material type the same, C2025. Here is 500 with 350. Here we have to choose the beam, M3 design only, as it is. I click OK. After this we have to define the slab sections. Add new property, slab 2, let's say, C2025, shell thin, 200 thickness. Click OK. OK. After this we have to draw these things, and the first thing to do in this case is to select all stories, just to make a little less work. Here we have to choose beam, moment release continuous. OK. So let's draw. As we can see in the 3D part, the beam shows up at the all stories. Because we select all stories here. I have to finish now with the beams, and after this we will make the columns, and after the columns we have the slabs. So this was all about the beams. Now we have to click SCC in keyboard. After this we have to click here, quick draw columns, and at properties we have to select CL. And now we have to be very careful now, because it sometimes it don't center the middle of the beams. Okay, the last one. Okay, I finish even this. So now I have to quick draw floor. We have to choose our slab, that was slab 2, and select all the floors. I finish even one, this. But at this part, because we have select all stories, but as you can see here in the base we do not have the need of a slab, so we have to click this one, move up list, we move up in list, and it shows up the base floor. So we have to click one by, oh sorry, because it was all stories here, sorry. Again, click uh, just a second, because I made a mistake. Now is only in this story, and I will select all the slabs, and then I will delete them, and in this case I will make the sign joint restraint and click fast restraints here to make them fixed columns, and after this we have to make here all stories a sign. No, just a second. We have to select again, and assign here shell loads uniforms, and we have to choose here 2 kilonewton load and give OK, and previous selection here again shell load uniform, but this time the live one 2.5 and give OK. Here we can go here, click with the right side of the mouse, and we can see the load pattern that we have here. So we finish with this part now, and we have to make the function, to define the function. Define function response spectrum. Click here, click Eurocode A2004, add new function, and this gives us a function that I will name function 11. This is a damping ratio that is 5%, and these are some variables that may vary from different types of soil, of building, and with us in this case we will leave it, we will change only the ground type from B to C, that I know that is for sure, and basically the other variables I will let them unmoved. So click OK now, and OK again, and after this we have to define the load patterns. So we have here the dead and alive. We have to add earthquake, that is seismic type, and Eurocode 8 2004. Here self-weight multiplier we will leave as 0, and we have to click here add new load. Another type is wind. This is, we have to choose wind here, 0 again, and Eurocode, where is, okay, Eurocode 2005, add new load. We have a lot of type here: super, dead, live, national, wind, snow, construction, etc. We will take only these 4. Click OK. Define again load cases. We will only check here. OK. Define again load combinations. I will explain by words. We will have 2 combinations. One combination, as we will name combination 1, we will add only two cases, dead and live. We will make the scale factor 1.4 and 1.6 here. Click OK and add the second one, the second combo with all what we have. And basically we will leave the scale factor, in this case, all 1. Okay, click OK then. After this I have to at analysis we have to make automatic rectangular mesh settings for floors. This table will show up and we will make it from 1.55, we will make it as 1 and then click OK. And after this, so let's try like this. I want to see the difference. Okay, makes no difference because some types of Etabs are different, some types are different. Anyway, sorry. Now I have to analyze just to be sure I have forgot anything. Okay. No, I think I'm okay. Till now I have to run analysis. I have to save it as FA in desktop. Okay. Now it will run the analysis, but as much as floors as they are, it takes longer. So I think a minute will be enough. Anyway, let's see. Here is the loads, dead and live load in every slab. Saving mesh information. So this is what it gives. Okay, it's nice and beautiful. If we click here start animation, it will shows up a little animation that I like it. I always want to see it. Okay. After this we have to go to display, force stress diagrams, and let's see. Okay, if we have to look the combo one, just to be F1 F2 F11, this will show up how the stress is I don't know how to say now, but as we can see, here are the beams, and the more red is the zone, the more stress and shear stress it has. So as we can see here, it's obvious. And this was this type, and here we have all the information and data that we need about the analysis. For example, the response spectrum fraction, the design preference, and the results here. There are very information very important. Here is the displacement, joint displacement. I will open this one just to show. Here we can see the maximum and the minimum one. After this, we have to go to design, concrete frame, view. So this is where we can change, for example, from Eurocode to another part. So this basically is how to a way to recheck all we have here. I choose Denmark, wrong, send default. Okay, click OK, go again, then design, concrete, and start check, design check. This is the last part of my presentation and my work. Basically what this will takes 1 minute, and this is the last part. It will give us all the information that we need about reinforcements and other stuff like shear stress, and it will give like information numbers here, here, or wherever. This is the main type. Let's wait a little bit. Okay, so this is what I said before. As you can see here, we can find all the information and all the analysis that we need about reinforcements,